Hi everyone, I am Matteo and I work for a company called nearForm. And today I'm here to talk about how to take your HTTP server to ludicrous speed. Now, be careful, ludicrous speed is from Spaceball. You have nothing to do with ludicrous speed or Spaceball, but it's actually a pretty good film, probably the best film of all times. I don't know, you decide. Anyway, all of this started a long time ago. And I did a first talk reaching ludicrous speed in 2015, where I talked about how to improve the performance of Node.js software by applying some knowledge on how the V8 engine works. So that was it. It's a good talk. Check it out. Now, this talk is about something different. So after the talk, that was talking about some principles and how to improve some micro benchmarks. However, what we could do is, what I started doing is applying that knowledge to other stuff. And in 2016, myself and my colleague, David McClemens, started working on Pinot. Pinot is a fantastic logger, and in fact, it's super fast and all natural because it's up to 17 times faster than alternatives on Node 6. Now, what does it mean? Well, it means that you can get some servers for free just by using Pinot. So you save energy. So we are very green. Come on. So as part of this journey, we have started developing some tools. One of which is AutoCannon. The other one is ludicrous. AutoCannon is an HTTP load tester. It's a HTTP 1.1 load tester. And it has a very trivial cross-platform installation. npm install AutoCannon, and it generates the same load as alternatives in C, like work and AB and whatever else you want to use. It's really fast, and you can script using Node.js. It's built using Node.js with a tiny part in C. ludicrous is a completely different framework, a completely different tool to build flamegraphs. Now, what is a flamegraph? Flamegraph is a visualization of the call stack of your application over time. So when you execute the React, you execute it targeting an executable, a Node.js application, and you start sampling over time using dtrace or perf, depending on your operating system, Linux or Mac. It samples the call stack of your application, and it plots all of them and it sums them up over, and then it plots a time-independent representation of it, where the largest a frame is, the more time it has seen that same frame. ludicrous and AutoCannon is a perfect combo of for improving the performance of web application. Now, so in 2016, well, I started thinking what we can apply after the logger and so on, and well, we'll see that in a moment. Anyway, this is about applying all these things in over HTTP for HTTP applications. So you probably have seen this. This is how you write a little, you send a JSON out with Express. You instantiate an Express application, and then you call app.get, you set up a route, and you get your request and response, and then you show response.send. You can also do the same in Node Core. Well, not really the same, but something very similar with lots of less things. By creating a server using the HTTP module and specifying a function that has the request response similar to which one the Express inherits from those, expand those, and then we return a JSON. Now, what happens is that Node Core requires 23,000 requests per second, does 23,000 requests per second, while Express does only 9,000. Where did it go? Now, let's use a flame graph. This powerful representations, powerful diagram. So this is the flame graph of Express. And you can see that you have two towers, big towers here, big stacks here, and these small towers here. Now, if you look at this small tower, it sees that at the top, which means the most hot function, is at the 3% of the time the application is sampled to be calling write generic in net.js. And then there are another 2.6%, it's actually in writing things in the kernel. Yeah. So these are untouchable. This is how things happen. However, this tower is Express itself. And in fact, we can open it up here in next, and we see that this next function comes from route.js. And then we have process param, which is still in router, defining router, and so on and so forth. You can even say that some functions have not been optimized. Like, for example, this one here has not been optimized, or what it is, trim prefix has not been optimized, and so on. So let's see where, so now what we can apply the same thing to Node Core. And this is the same thing, the flame graph of Node Core. And we can see that the two towers that were expressed were missing. So as we expected, it was something that was happening within Express that was slowing things down. Now, if we go back, we can actually see that we spend a lot of time at the top here just calculating some e-tags and doing some crypto stuff. Okay, this was one of the hardest things possible for this. It's doing some crypto for each request. Probably it's computing a hash for a e-tag. Yep, that's it. So what can we do? Well, I set up this journey, and I wrote this framework called Fastify. Myself and another mad Italian one called Tommaso della Vedova, and we start Thomas della Vedova. We started working on Fastify, and Fastify it's a new web framework, and it can work in a similar way to Express and Happy and others. In fact, you can instantiate it, set up your route, you get a request and reply object. These are not the same one from before, and you can send a JSON using .send. One of the cool thing about Fastify is that you can specify a schema for your response, and this gives us the greatest performance, as we will see later on. In fact, Fastify can improve a lot the performance compared to Express, because you can go at around 16,000 versus 9,000 versus 26,000 of Node Core. And this is a framework of Fastify. And in Fastify we have, as you can see, one of the most one now. One of the top ones is write generic, and write generic is it's 5% of the almost 6% time at the time at the top of the stack. So it's spending a lot of time writing. And in fact, here we see a little bit of things from Fastify itself, but you know what the most top method is in fact setting the headers. And it spends some time doing reply.send, but that's about it, okay? So it's not happening a lot. Here we are doing some more things, outgoing message and more internal stuff, some regex, but not a lot, okay? It's not doing much. However, providing us a good API. How does it work? Well, we'll see that in a moment. But this is a feature comparison. Fastify and Happy both have, all of them have a router. Express has its own middleware format, which Fastify supports, connect middleware. So Fastify, you can use middlewares from Express or Restify, you can use them in Fastify. Then you have plugins, you have validation, you have hooks, you have the decorators, you have logging embedded, and you have, for example, async await support, which is not part of Express. So how did we get fast? Well, the basic technique is represented in this diagram. And in fact, you have your developers write some code, you write some code, and then your code use Fastify. Now, Fastify, when you start using it, it actually pre-initializes some very fast data structure and very fast functions, so that they can allow a very extremely optimized access when a request comes in. And now we will see some of those fast data structures. So one of the major problems that we wanted to solve was the problem with closure. Now I did a full talk on this. It is reaching ludicrous speed one, so go and check that out. But the problem with closures is that you have this typical function here with a callback L type of system, and you see that you have this big data function here. Now this big data object, it represents a good chunk of data. Now this big data object is then passed to a remote call. Then we have this little function that gives us something, and then we store something with something, and again we return something else. Now this block has two problems. The first one is that big data is still in scope when this function is executed. So it's maintained throughout up until two asynchronous operations. Now, the problem with this is that big data, it might not be needed. So because it might not, it's not needed for this, but it can be brought out from, because it is still in scope. So that can be helped much. And the other problem is these two functions are really short-lived, so that they are hard to optimize. Now, if one of those two functions, you have a for loop for doing some operations, those will be very hard to optimize by V8. So let's see how to fix this. Now, in order to fix this, we do two things. First of all, we create a new call store sometime function, which we'll show in the next slide, and which we just pass something and the callback. Here, in this short-lived function, we need just to handle the error and then call something. Now, this function, call store something, now can be heavily optimized. So because it can be heavily optimized, then we can avoid a lot of problems related to performance. The other bit is that big data exits scopes here. So it also is our garbage collector. And this is the call store something. Now, with call store something, this function can be optimized. And, you know, the only thing that is left in scope here is the something object. In Fastify, we have no closures at all. It doesn't allocate any closure whatsoever. The technique they use is called Usify, and again, go watch my Reaching Ludicrous Peak talk. So an extremely fast data structure that we use internally is related to routing. And it's a library called Find My Way by Thomas Della Vedova. It is the library in here, yeah, crazy fast HTTP router. And this is Thomas. Hey, Thomas, hi. This function, this router is extremely fast. It's built on a radix tree, and this is built. We built this in the first place to avoid closure allocations. And again, it's perfectly safe to use. It doesn't have any problems. We are testing it extensively. This is the different performance of the Find My Way router. For a static route. Yes, it's fast, okay? So you should probably, if you are not using the internal Express router for whatever reason, whatever router you are using, probably you should check it out. It's really cool. The other thing that we built is related to JSON Stringify. Now, JSON Stringify has a simple problem. First of all, in order to serialize a JSON, it needs to be a recursive function, because it cannot really be optimized by V8. And it cannot be optimized by V8. Now, this is because it's recursive and also because it's very generic code. So it cannot be type specific. V8 can optimize being on the type that is seeing all the time. We wrote this library called Fast-JSON Stringify that can double the speed of your stringification, of your normal JSON Stringify. How we do that? Well, we do what we call schema-based JSON rendering. Now, this happens because this can generate code based. It dynamically generates code. When you instantiate Fast-JSON Stringify, it generates some code based on the schema. Now, this is perfectly safe because the new function that is generated at start time, because before we start accepting any HTTP request. So this is super safe to use, and it's also very fast. We have said that Fastify also consumes Express and connect middlewares. And in fact, it uses this little module called MIDI that you can use yourself if you want to be compatible with Node Core. Just use plain Node Core, you can use this module as your middleware engine. Now, MIDI, if we add all the Helmet middlewares to Fastify, we can see that Fastify is faster than Express at doing this. And how did this happen? Well, this is the Express with Helmet flamegraphs, and you can see there is very high, sky-high towers where which are our middlewares. Okay, you can see them here. While in Fastify, those same towers are way more tiny. Okay, and now I'm not saying that you should use middlewares, but for compatibility reason, it might just make a lot of sense. Also, we use, we can, like Happy, we can validate the input of parameter, and we use JSON schema to do so. And fortunately for JSON schema, that because it's a standard, we have multiple implementations, and we use AJV here, not DJV, because of two things. First of all, when we started working, there was no DJV. And second, because DJV has way more problems as 16 failures through the spec, while AJV has only one failure by implementing the spec. So it's we choose AJV because it's the most fast and most correct at the same time. So this was Fastify, and now it's time for a demo. So wait a second, where it is? Yeah, here. It's time for a demo. So we can open a little server here. We need to always put use strict, folks, and we can create our Fastify instance. Then we can call fastify.get JSON at JSON, and we can add the request and the reply object, and we can say reply.send word. Now we can call Fastify listen 3000. Now we can do server, and then we can curl localhost 3000 JSON, and we got hello world. Fantastic. Well, this doesn't mean much because we are not really doing a lot of things here. Let's add a template. So let's register first a plugin called point of view. And we need to pass in the engine that we're going to use, which is Marco. And now we can change, for example, our home page to /, and instead of doing this, we can do view and put index.marco. Let's see how it goes. Here we go. It's still working. Now let's see how index.marco is written. This is just a basic Marco file. Okay. Now, if you go back to server, you might, when you are developing your application, in fact, you don't want to put everything on the same file. And the technique is dividing your applications in plugins. So what we can do is fastify.register and say require subsystem, which is a subpart of your applications. Now, in subsystem, let's create a folder because we want to show all the encapsulation of the encapsulation characteristic of Fastify. Within subsystem, we create a new file index.js. And in order to write a Fastify plugin, what we need to do, we just need to export a Fastify subsystem. We need to just export a function with the Fastify server, the option of our system, and the next function. Remember always to call next, otherwise the application won't start. So what we're doing here, first of all, we register again our plugin, or our point of view plugin. Why 2 times? Well, because we want to change some options. Okay, so and what we want to change is the fact that we have a template folder, and is this directory. And now we can copy index Marco and put in the subsystem and call it page. In fact, in our subsystem, we can also write down that we have a prefix which is /abc. And in the subsystem, we can say that if we get /, which means get abc, because at the end of it, we have a request and reply object, and what we are going to do is reply.view page.marco hello world. Let's see if this starts. It started. This is still working. And this, it's working again. However, this is the same thing. So, if you want to show it's different, hello from plugin. So those things are different. You can see that it has been updated. So this was Fastify. Remember that most codes do not need to go ludicrous speed. So if you don't need to write fast code, fast and performance code, don't even have to change. It's a really good, whatever you're using is perfect for you. But if you care about stability and scalability and scaling your application, well, maybe give Fastify a shot. There is also a new blog post that myself and my colleague David McClemens have written related to Turbofan, the new compiler of the new optimizing compiler by V8. So check that out. It's on the blog there. This presentation is available on GitHub and HTTPS on my github.io thing, and also as a source on github.com. This is me. I work for nearForm. We are a Node.js consultancy company and professional services. I'm also part of the Node.js CTC, so I am also part of the group that governs Node.js. I wrote a lot of things. I maintain a lot of software. So as you can see, I work most of my time on open source. Thank you again for listening for this big ramble, and I hope you enjoyed it. And let me know if you have any questions around Fastify. And check out our new website on www.nearform.com and also at matteocollina.com if you have questions. Bye.